Hi guys, this is the cover of the course packet that you can buy in the bookstore, and you'll notice that it says Spring 2020 edition, so you can um, ignore that. It is the one for the semester. Way down at the bottom, it says reproduced Spring of 2021. So sorry about the possible confusion with last year's date on it there. But you'll want to pick this up, and a lot of the lectures that a lot of the YouTube videos that you will be watching for lecture this semester will be using pages out of this packet. And so let's take a look at the first page of the packet here. What I want to say is that one of the course objectives of the second semester of organic is to be able to design multi-step synthesis of organic compounds. And so one of the things that you do in figuring out how to make a compound is you work backwards. You start with the product and you think, how, if I worked backwards one step, what could I make it from? And then from that you work backwards another step. And that's one of the things that we began to study first semester back in chapter 9, sections 7 through 9 in chapter 9 when we learned about acetylide synthesis. And this was our first method for making carbon-carbon bonds, which gave us the ability to make bigger molecules from smaller molecules. And during this semester, we're going to learn a lot of new ways of making carbon-carbon bonds, and we'll have a much more versatile set of tools, and we can learn how to make lots of different larger molecules. So all of the reactions that you learned during the first semester of the course are tools that we'll be using in organic synthesis. So it's essential that you remain familiar with those reactions. And so I've put together this blue sheet here. It's two sides to it to help jog your memory on some of these reactions. And so on it, you're going to be working backwards one step, or sometimes two steps, where it says specifically two steps. You're going to be working backwards, and you are going to go to a specific functional group. And so this first column provide the missing alkene and the reagents to come up with this final product. So you're being told work backwards to a specific functional group. So you're already given the functional group. What you have to come up with is the appropriate reagents, and then you need to think about, as we always did first semester, the stereochemistry and the regiochemistry that's involved in the reaction. So here we have a column of reactions that are that we're making products from an alkene. Then over here we have a column of reactions where we're making things from an alkyne, either one step or later down two steps. And then on the back side, then we are making these things from an alkyl halide, and we are making these products over here from an alcohol. And some of these reactions we spent more time with first semester. Some of them we were introduced to them briefly, and then we moved on. But they are all important reactions that we need to have in our toolkit for synthesizing larger molecules. So maybe we can look at a couple of them here. First one, okay, so we're making it from an alkene, so part of it is what's going on here is we have the same carbon skeleton in the reactant as we do the product, and this is a 1, 2, 3, 4 carbon chain. And then we see in this product we have a bromine attached to this carbon and a bromine attached to that carbon. So as you're thinking about where the double bond would be, you should automatically be thinking, well, it would have to be the double bond in the middle, because in an addition reaction you add one thing to one end of the double bond and another thing to the other end of the double bond. And if we're starting out with an alkene, then these bromines are what we have added to it, and so you automatically know that you're adding Br2. This one's fairly straightforward. And the other thing that you should remember is that bromine adds in anti-addition mechanism. And so if one bromine adds from one side, then the other one comes in from the other side. So here we are starting out with anti-addition, and the way this product happens to be drawn, it's perfect because we have one bromine that's coming out towards you and one bromine that's going away from you. And so if that was added to this alkene in the middle, then that alkene would have, to begin with, had a methyl group going down on one end and a methyl group going down on the other end. So it would be a cis alkene. And so then we can just go ahead and draw that. Here is our alkene, and we have methyl group there, and then the hydrogens on the top side. So if one bromine added on the right from the top side, then since it's anti-addition, the other bromine would have added from the bottom. So it's important to figure out where the double bond used to be, and then if there's cis-trans possibilities, figure out if it should be cis or trans. So that's the stereochemistry there. And so the next one, you're going to have to do some rotation, because here's another one where we're adding Br2, but it looks like both bromines have added from the top. That would be syn addition, and you know that's not possible. And so the original spine here of the alkene looks like it was cis, but you know now that it would have to be trans. If we're going to add anti-addition to end up getting the bromines looking like they're together here, then there would have been a trans double bond. And maybe that was a little bit too fast for you, since you didn't spend a lot of time thinking about that over Christmas. But you can certainly go back to the chapter and take a look at it, or review that. So all of these are coming from an alkene, and you got to figure out where the alkene was. So this is pretty straightforward there. Another one may not be so obvious. So right here we've added a bromine, and you know that that if there was a double bond here, you had to add one thing to one end and one to the other end. And so if there's a bromine here, there used to be a double bond here, or there used to be a double bond here. And so what you have added, what have you added? You've added a bromine to one end, and what have you added to the other end? There's nothing here that you can see, but you know that these are hydrogens, right? And so you've added HBr to a double bond here, or added HBr to a double bond there. And so the reagents, the reagent that you'll be using is HBr, and you know that HBr adds by Markovnikov's rule. And so you know that the hydrogen adds to the end that has the most hydrogens already, and the bromine adds to the other end. Or the more generally speaking, the electrophile, the thing with the partial positive or positive charge, adds first, forming the more stable carbocation at the other end of the double bond, where the nucleophile adds. And if you spend some time thinking about it, you'll realize that, sorry, I have a frog in my throat. Drink a little water. If you put the double bond here, then the original compound would have a double bond, and it had one alkyl group at the left end and one alkyl group at the other end. So there's no preference adding the bromine to one end to the other. So if the double bond was here, half the time the bromine would add to this end, and half the time the bromine would add to the other end. So if we put the double bond at the other end, going the other direction, then here is your original compound. And as you know, the hydrogen adds to the end with the most hydrogens, and the nucleophile adds to the other end there, and you will only get this product there if you choose the alkene to go in the right position. So you have some important regiochemistry to consider there. So just looking at a couple of them, and the sheet is for you to work on, and you can go ahead and work through things. I will post on in the Canvas course a key to it after a few days, and you can check the key after you've done the best you can. Certainly you have a textbook that at the end of each chapter has summaries of reactions, so if you need to, find the appropriate chapter and kind of check into that. But again, these are reactions that you need to know and be able to use as tools. Good luck.